Hi everyone. As a part of Together for Our Planet campaign, I would like to tell you about energy transition by answering the following three questions. Energy transition: why, what, and how? Why is it important? What's being done in this regard based on the UK's case, and how other countries can apply the UK's experience? Together for Our Planet campaign is running to promote and build momentum for the COP26 event, which will take place this November in Glasgow, where I live. COP26 is the 2021 edition of the United Nations Annual Climate Change Conference. COP stands for Conference of the Parties. Every year, world leaders meet to make important decisions about how humanity tackles climate change. And I am Dr. Alfia Wright, PhD in Energy Economics, energy economist specializing in low carbon technologies and energy transition. Let's begin. The presentation consists of three parts. The first part answers why energy transition is important and what it means. Energy transition, as its name stands, is a pathway towards the transformation of the global energy sector from fossil fuel-based to zero carbon by the second half of this century. This definition is given by the International Renewable Energy Agency, IRENA. It is an intergovernmental international organization founded in 2009 to support the use of all forms of renewable energy sources. So, the energy transition can be done either directly by replacing fossil fuels with renewable energy sources or through transitional technologies, in other words, bridging technologies that convert fossil fuels into low carbon fuels. For example, carbon capture, utilization, and storage technology can be applied to natural gas to produce blue hydrogen, or extend the use of coal or gas in power generation by reducing emissions from the process. The availability of transitional technologies makes it possible to extend the use of fossil fuels while technological, financial, and other favorable conditions arise for the full transition to renewable energy sources. The use of fossil fuels in their pure form is already being questioned by the world community, so that some investment institutions have already started ceasing to invest in fossil fuel projects. I have presented all types of renewable energy sources here, like biomass, biofuel, hydropower, wind and solar power, tidal power, wave power, and geothermal. Here it is worth noting that green hydrogen can be produced with electrolysis using renewable energy from wind or sun. At the heart of the energy transition is the need to reduce energy-related CO2 emissions to limit climate change. The Earth's surface temperature is rising every year. According to NASA estimates, as of 2020, the temperature increase is already over 1 degree Celsius since the pre-industrial period in 1880. And we know the Paris Agreement aims to limit global warming to 1.5 degrees Celsius above pre-industrial level. We can see here that fossil fuels are the primary energy source, accounting for almost 84% of the energy consumption. The rest, almost 16%, came from the low carbon sources, which are the sum of nuclear power and renewables. Yes, the share of renewable energy is growing each year. However, global energy consumption has been growing at even quicker rate for renewables and nuclear to displace the fossil fuels in the global energy mix. Burning fossil fuels for energy production results in 3/4 of global greenhouse emissions. To cope with climate change, we need to shift away from fossil fuels to an energy mix dominated by low carbon energy sources. The video on the right, it is about carbon budgets and illustrates the amount of CO2 that has already been emitted into the atmosphere since the pre-industrial period. As a result, you can see the share of carbon budget that has been used up to date and how relatively little carbon budget remained before we reach the 1.5 degrees Celsius mark of global warming. The concept of a carbon budget became known because science has established that there is a linear relationship between the total amount of CO2 we emit into the atmosphere and the degree of global warming. Hence, by knowing the degree of global warming that the globe aims to maintain, scientists were able to calculate the total amount of cumulative CO2 emissions allowed to stay below a given global warming level. On this graph, you can see CO2 emission reduction curves, but the rates of global climate mitigation depends on how soon the emission reduction begins. The earlier the world or an individual country begins to reduce CO2 emissions, the less the degree of necessary emission reduction is required to stay within the carbon budget. In contrary, the later the emission reductions start, the higher the required cuts are needed. It follows that it would be more logical to start as soon as possible rather than postpone. However, we are not seeing it happening. As you might have noticed on the background, I displayed warming stripes by Ed Hawkins, a climate scientist from the University of Reading, which visually portray long-term temperature trends by replacing numerical data points with colors. The main message of this slide: yes, the global surface temperature is rising. There is a direct link between global warming and anthropogenic activity. We must cut greenhouse gas emissions to achieve energy transition is essential and even more urgent than we could have imagined. We have examined why energy transition important, and in the next part of the presentation, I will discuss how the UK has addressed its energy transition and climate change mitigation goals. The UK is the first to set the legally binding target to reduce carbon emissions by passing the Climate Change Act in 2008. The Climate Change Act decreed by 2050 to reduce emissions by 80% compared to 1990 levels. The Act created Climate Change Committee, an independent statutory body to advise government and parliament and determine carbon budgets to achieve this goal. And from previous slide, we know what the carbon budgets are. The period up to 2050 was divided into 5-year interplan targets, and a carbon budget was established for each period. The carbon budget set the amount of greenhouse gases emitted by a country over a 5 years period. Carbon budgets are announced at least 12 years in advance so that businesses and households can adapt. The first 3 carbon budgets were established in 2008. The third carbon budget is ending in 2022. However, the country managed to outperform its goal of a 37% reduction, and it has started the implementation of the 4th carbon budget ahead of time. The 5th carbon budget was announced in 2016 with the goal to reduce emissions at least by 57% by 2030. The Climate Change Act was amended in 2019 to a new net zero target, requiring emissions to be reduced by at least 100% net zero below 1990 levels by 2050. Once again, the UK was the first major economy to commit to achieving net zero. Likewise, for the first time in the world, the UK began to take into account emissions of international aviation and shipping. This year, the government announced a 6th carbon budget for the period of 2033 and 37, aiming to reduce emissions by an ambitious 78% by 2035 from 1990s level. In summary, we can note that UK's experience can be divided in 2 phases. The first phase can cover period up to date, and the second phase can include the forthcoming 4th, 5th, and 6th carbon budgets. And let's have a look at how the UK managed to achieve its first 3 carbon budgets, followed up what it's going to do to achieve the rest. So, up to date, in 2020, measured from 1990s, emissions had fallen by 48% over a period when the economy grew by over 70%. As we remember, the target was 37% reduction by 2020, so they outperformed it. This is the most substantial emission reduction in G7 over a period when economic growth was above the G7 average. It should be noted, however, that the drop in emissions between 1990 and 2019 was 43%. And this additional reduction that we can see have occurred reflect on, in fact, of the impact of COVID-19, much of which is not expected to be permanent, as noted by the Committee on Climate Change. In the graph on the right, you can see historical and projected emission curve, as well as carbon budgets. And all carbon budgets have been approved at the legislative level, including the 6th carbon budget. So this picture is not up to date. Let's look at how the UK met its third carbon budget, first by noting its progress in numbers. The UK's progress in numbers, the power sector accounts for almost all of the recent progress on the UK's emission, which has seen dramatic changes over the past decade, largely due to reduction in the use of coal in power generation. Coal production has dropped by 91% in the past 10 years, and the share of coal in electricity generation does not exceed 2%. There are currently only 4 coal-fired plants operating in the UK and will be decommissioned in 2024. The decrease in coal consumption in the power industry was facilitated by replacing coal with natural gas and subsequently renewable energy sources. There was a 500% increase in the amount of energy from renewables, which are connected to the grid over the past 12 years. Renewable electricity generation is increasing yearly and in 2020 outperformed annual fossil fuel generation for the first time. Jobs, of course, have been created through the development of the low carbon technology industries, and over 42 billion were invested between 2010 and 2015. And of course, it's worth mentioning investments and grants for research and development in carbon capture utilization and storage projects and hydrogen projects. For example, hydrogen and fuel cell supergen is funded by the Research Council UK Energy Programme as a part of the government's Sustainable Power Generation and Supply Initiative in 2012. There is a lot to be said about various initiatives and mechanisms applied in the UK, which incentivize the development of low carbon technologies, which will require a separate presentation. However, I've tried to cover most of them here, but I will only summarize and highlight few of them. The most simplistic, in my opinion, of all tools is the encouragement to transit to more energy efficient light bulbs. Initially, as a part of the the UK has started phasing out traditional or incandescent light bulbs by 2012. The UK has started phasing out halogen spotlights in 2016, while from September this year, the sales of halogen light bulbs have already been banned, with plans to remove fluorescent lights from shelves in 2 years' time. The report states that a shift to LED bulbs will cut 1.26 million tons of CO2, which is equivalent of removing over 500,000 cars from UK roads, while helping save British consumers a £75 a year on their energy bills. So it is worth noting that LED lights last 5 times longer than traditional halogen light bulbs and produce the same amount of light but use up to 80% less power. Another mechanism that I want to mention is feed-in tariff. Again, in 2010, the UK was the first country to introduce feed-in tariff scheme to promote installation and application of small-scale renewable and low-carbon generation technologies like solar PV, wind, micro-combined heat and power, hydro, anaerobic digestion. And this could be done by everyone, including households, landlords, businesses, and even organizations such as schools and care homes. So feed-in tariff pay the generator, which are these agents, like as I mentioned, household, landlords, a certain amount of energy that the generator themselves consumes. So the government was paying generators for the electricity they were producing and consuming. Also, the scheme was paying an additional export tariff for the excess electricity that these generators were feeding back into the grid. Another mechanism that I would like to mention here is the contracts for difference, because as I mentioned on the previous slide, there was a 500% increase in renewables generation, which I mentioned on the previous slide, and this was enabled by contracts for difference mechanism. It is the government's main mechanism for incentivizing investments in low carbon electricity generation. So CFDs, they protect developers from volatile wholesale prices by providing long-term, high upfront cost, and at the same time they protect consumers from paying increased cost when electricity prices are high. So if we look at all these schemes and mechanisms, we can notice that the UK government aimed at both households and their habits, as well as private sectors and industries. So now let's have a look how things are going now with emission reductions and what UK needs to do in order to achieve them. If we look at the energy consumption by source, we can see that the fossil fuels, they still dominate despite the decline in the use of coal. And if we look at the emissions by sector, the energy supply sector represents the second largest source of emissions. So despite the prevalence of renewable energy in electricity production, natural gas still accounts for a significant share in electricity production. And so now even the use of natural gas is no longer an option for sustainable development. It is worth noting that despite the country's growing population, there is a decline, we can see clear decline in electricity production, which implies improved energy efficiency. And finally, if we reallocate emissions from the energy supply sector to end users, businesses and households, they become the largest polluters. So in order to address these emissions, the government came with a 10-point plan for a green revolution, which I will talk in a minute. So the 10-point plan aims to reduce UK's emissions by 180 million tons CO2 equivalent in the next decade. And the plan aims to attract 12 billion of government investment and potentially 3 times as much from the private sector to create and support 250,000 green jobs. And despite, however, all these efforts, the Committee on Climate Change is warning the government that they're not doing enough to reach the carbon budget for and the rest. So another thing to mention here that the 10-point plan includes the development of several ambitious low carbon technologies like jet zero, green ships, hydrogen, advanced offshore wind farms, carbon capture, utilization and storage, greener transport and buildings. So if we summarize the UK's efforts in tackling climate change, we can see that it picked the low-hanging fruits. So in the recent decade, the UK has managed to decrease emissions by 29%, and it achieved its first, second, and third carbon budgets. And they managed to do that by improving efficiency, phasing out coal, and increasing renewables capacity. However, in order to decrease emissions further by another 31% in the next decade, it requires to think out of box, apply new ambitious technologies, and attract significant investments. So now we have approached the final part of our presentations. I talked about energy transition, why it is important, and how the UK managed on planning to tackle its climate goals, climate mitigation goals. Now in this section, I will highlight few steps that other countries could take based on the UK's experience. So based on the UK's experience, other countries might apply some of the UK's lessons learned and set the following near-term goals. Like by near-term, I mean the goals for the next decade, like improve efficiencies, increase use of less carbon intensive fuels, so transform from coal to gas and from gas to renewables, hence increase use of renewables, plant more trees, change consumer habits. And in order to do this, they can set climate change mitigation targets, audit all processes and sectors, identify areas where they can apply these near-term goals. Because as we can see, to do these things, it doesn't require much of know-how, sort of knowledge. So countries can set carbon budgets and mechanisms. They need to, of course, secure finances, identify R&D areas. Once they achieve near-term goals, they can move on to the goals for the next phase, more advanced, where they will need to hard to cut emissions. And in order to do that, they can apply advanced technologies, develop green transport, green hydrogen, apply carbon capture, utilization and storage, and phase out coal or do both. Of course, they will need to think about green investments, seize out investments in fossil fuels and projects, and develop incentive mechanisms. In conclusion, some food for thought. I would like you to think about, if the earth were an apple, then the people would live in 1/10 of the apple skin, where I refer to the thickness of the habitable atmosphere. So now you can imagine how small and fragile the atmosphere we live in. Therefore, let's take care of our planet. The only pale blue dot in our solar system where humanity can exist. This is a famous picture of planet Earth taken by the Voyager 1 probe in 1990 from a distance of about 6 billion kilometers. Look again at that dot. That is here, that is home, that is us. So let's do our best to protect our planet, this pale blue dot. I am Dr. Alfia Wright. Thank you for being with me and learning about energy transition, about the UK's experience in tackling climate change. And if you have any questions or suggestions, write them in the comments below. Share this video, like this video if you enjoyed. Thank you very much.